Okay, good morning guys. Just going to go over a few of the problems from the 2-element series circuit worksheet that was put up on the D2L. Just to get us a little bit more practice, or to show you guys how to potentially solve this, just in case you're having some difficulties. I don't think you will, but it's always good to be prepared. So we're going to start with, I've got question 1 from the 2-element series circuit. It's pretty much a basic one. What I've done is I've drawn on the board here everything that was given. They gave us the current, 3.2 amps. They gave us a voltage drop across the resistor number 1, or load 1, at 40 volts. And then they gave us the resistance of our R2, or load 2, at 25 ohms. So, keeping in mind the rules that I have over here on the right-hand side of the board, you'll see that my I total is equal to I1 equal to I2 equal to I3. So that means that my current that started here at 3.2 amps is going to be the same throughout the entire circuit. And that's a key point, okay? Because utilizing that current, we can multiply it by 25 ohms here to give me my voltage across V2, all right? And if I did that, where am I looking at? That's going to come out to 80 volts. So that was 3.2 times 25, should be 80 volts. All right. While I'm there, I can figure out the power. That's 3.2 amps times the 80 volts, which should give us 128 watts. All right. Moving back here, we can solve for the missing pieces of information utilizing that current and the voltage drop that they gave us. So in this case, we've got 40 volts divided by 3.2, okay, which will give us a resistance of 12.5 ohms. And 40 volts times 3.2, oh, you know what? I think I did something wrong here. That's 128 watts. My apologies. This guy over here is going to be 256 watts. All right? So, lastly, we can look at our totals. If we've got 40 volts here and 80 volts here, we know that in Kirchhoff's law, the sum of all the voltage drops has to equal the source. So that makes 40 plus 80 giving us 120 volts. 120 divided by the 3.2 will give us the R total, or we could add up R1 plus R2. Either works. Okay, so 25 plus 12.5 gives us 37.5 ohms, and my power total would be the 128 plus the 256, which will give us 384. All right, what we can do next is we could verify using Ohm's law and Watt's law. 384 divided by 3.2, that should come out to 120. Okay, and 120 divided by 3.2 should give us an R total of 37.5 ohms. It's always best to double check your work, and I prefer you to always use what was given in order to try to solve as much as you can, rather than introducing wrong numbers or wrong answers into an equation to give you more wrong answers down the line. Okay, so that's question number 1. Now, if I reboot this, and I'm not going to go through the entire worksheet, but I will pick and choose a few here. So the next one we see, let's just jump down to number 4. So number 4, we'll call this one number 4. Circuit number 4 gives us an E total of 208 volts. All right, they give me a current of 8 amps. They give me R2, or a load 2, of 10 ohms. And that's all they give us. And I know you might have been wondering, well, what do I do? How do I solve all of this information? Okay. We can very quickly come up with a V2 using our 8 amps times our 10 ohms to give us 80 volts. Okay. And if we knew we had 208 up here, 208 volts subtract the 80 volts will give me what do we get? 128. Okay, so now we got a voltage drop at each. We've got a current, so we could simply solve for the rest. Over here, if we stuck with this, 128 divided by 8 is going to be 16 ohms. And 128 times 8 is going to be 1024 watts. And over here we can go 80 times 8 to give us 640 watts. Okay, and moving up here, we go 208 divided by 8 to give me my R total of 26 ohms. Or we could have gone 10 ohms plus 16. Okay, and then my power total is 1024 plus our 640, which gives me, I see, 1664. Okay, not too bad. I think I'll cut it off there. That's a couple of quick examples. If there are others that I go through, I might make a second video on this, just in case there was a couple more difficult ones. But there's a quick little video explanation, and yeah, see you in class. Thanks.